So this is a projectile motion problem. In this problem, we have a bullet fired from a level ground at an angle of 15 degrees with a velocity of 70 meters per second. And there are 5 things we need to find: the initial vertical and horizontal components of the velocity, the time it takes for the bullet to reach its maximum height, the value of that maximum height, and the bullet's range. So first I'm going to draw a picture. The bullet follows a path. Something like this. And this is our initial velocity. We know this is, what did we say, 15 degrees. So in question A, V naught y and V naught x. We have a trig triangle that looks like this. This was 70. This was 15. And these two arrows become V naught x and V naught y. So V naught y will be 70 meters per second times the cosine of 15 degrees. And V naught x will be 70 cosine 15 degrees. I can go ahead and calculate those out later. I'm not going to bother right now, but you're just going to use SOHCAHTOA to find those values. Now, if I want to find the time it takes to reach the maximum height in part B, I'm really looking at the y direction here. So from the y direction, I have the following information. V initial y is 70 sine 15. V final y will be 0 because we're at the peak. The acceleration in the y is negative 10 meters per second squared. And so if I want to find time, I'm going to use A equals V final minus V initial divided by t. So t will be 0 minus 70 meters per second sine 15 divided by negative 10. And that gets me 1.8 seconds to the peak. Now, I did not ask the question, but a conceivable question would be, what would be the total flight time for this bullet? And the total flight time would be 2 times 1.8, or 3.6 seconds. The next question was to find the maximum height. So again, I'm looking at the y direction. Remember, a key idea in projectile motion is that you really only can look at one direction at a time. The only quantity that applies to both the x and y direction is time. So in this question, I'm going to try to use the following equation to find a distance. Sorry, let me clean that up. With delta y. Now, I'm putting subscripts in to show y's everywhere. I change d to delta y, v naught y, ayt, to remind myself that I can only sub in y values. I know everything in this equation but what I'm trying to solve for, which is delta y. V naught y, we found earlier, is 70 sine 15. We just found the time to reach the peak. I know the acceleration is negative 10 meters per second squared. And I know the time squared is, or I know time again is 1.8 seconds, and I need to square that. I want to point out something here. Notice that the acceleration is opposite in sign to my velocity. I made that positive because the ball is slowing down. It's moving upward but slowing down, so the velocity and acceleration have to have opposite signs. So when I calculate I get 16.4 meters. And it's a positive value because the bullet is rising upward. The last part of this problem is to calculate range. Quick reminder on vocab here. Range is the word that means delta x, so I'm using the x direction in this case. This is actually the easiest of all these questions because there's no acceleration to consider, right? Remember a big idea, ax is 0. I'm actually going to use the same equation I used in the last problem, but change all the subscripts to x's. So I'm looking for distance in the x direction, but acceleration in the x direction is 0. So I know from question 1 what the initial velocity of the bullet was horizontally. It was 70 cosine 15. And now the total flight time is what we use here. So it's going to be 1.8 seconds times 2, because we're looking for delta x for the entire trip. And I got 243 meters. This is the end of this practice problem.